All right. Hey guys, your homework tonight is to finish the task you started on Friday and we did on Monday here. So this was rate of change assignments. You should have an idea what a rate of change is and maybe explain how it might be kind of the same thing as slope, but maybe slightly different. You might need to say a little bit more if you're describing the rate of a change of a particular situation. Remember, situations are one of the four ways that we can represent math, right? Situation, table, graph, and equation. So anyways, your goal is to finish this. You got to get through slide 20, but you also want to know how to do it. That's why I wanted to film this video in case you may be struggling, or you just want to watch this as a companion video to make sure you're doing it right and you're getting everything out of it here. Okay, so some people have finished. Maybe you'll watch the video again. I need to keep this less than 15 minutes anyways, because notice here, Reg is going to start at 1:40. It's 1:21 when I'm filming this right now, okay? So anyways, we did slides 12 and 13 together in class. So maybe we can jump to it here. There's some kind of answers from some people here. So maybe we can look at one that looks solid. This one here looks solid. Pierre Simon. These are all fake names here, which you've used before, okay? So anyways, this person started pretty good. So again, the thing that we're starting out with new here today is that in addition to a rate of change, right, we're going 3 feet every 4 seconds. One way you know that's a rate of change, 3 feet every 4 seconds, is that both variables are talked about here, okay? Both variables talked about here. So in this first one, it had to do with Danny's situation. So that was the rate of change was this, this over this, okay, which is plus 3 feet. Look here, this is 3 feet. Oop, 3, Oh, it's a line. That's the problem. So this is happening in class earlier too. It's a line instead of a curve. Okay, plus 3 here, and this is plus 4. Look at that, plus 4 on my x-axis. So I know that I have a rate of change in this one because this is Danny. We did it before. Oops. 4. Man, writing with Desmos here is rough, but hey, it's the best we can do. Okay, plus 3, plus 4. So that means in 4 seconds, right? In 4 seconds here, Danny was traveling 3 feet. Look here, distance traveled. That's your dependent variable. That's your change in y. Okay, is feet. Okay, change in x is plus 4. That's 4 seconds. Okay, and a rate of change, we'll be talking about both at the same time. Oh, my hair is a mess right now. 3 feet change every 4 seconds. Okay, so the thing that would change different is that Daniela, she's younger, right? She's younger. Sometimes you give people a head start. Okay, so she's given a head start in our race that we're going to talk about in a second, and that she starts 5 feet ahead, which is right here, 5 feet ahead. There we go. Okay. So the idea of this is actually a direct variation graph right here, right? Because it directly varies. The y value is always 3/4 of what the x value is here anyways. So we've seen direct variation already. This is different than direct variation. This is just a regular linear function that you have here. We've just shifted the whole graph up by 5. Okay. Interesting. So the equation here is y. You can see the equation on the next slide, but it's y equals 3 over 4 x plus 5. And notice this here, actually. You might want to notice this here. I think it'd be important, a good thing to notice here, that equation is very similar, right? Very similar to this line, right, that we just shifted up here, okay? What does it have the same? So when lines are like this, when they just shift up and whatnot, when they just look pretty much the same, but they have a different starting number, then they're parallel to one another. I'll define what parallel means later this year in case you haven't really heard that too much, but you'd have the same slope, right? We have the same rate of change here. We're just shifting up here. We have the same rate of change. So the slope determines, right, how it's growing. So if we just start in a different place, you know, these won't be in the same place ever. So these will be parallel to one another. Anyways, this is just y equals 3/4 x was that one, and did that one on Friday. Okay, moving onward here, let's maybe check out Pierre's work that we have here. Pierre's was pretty solid in the first one. So they didn't put, they did put the equations. Okay, very good. So this we had to do in class. So hopefully make sure you put your equations in here. The thing that changed was this one, right? Was this one here. So now, if you look back to previous slides, all 3 of these graphs, right? The green, the red, and the other, and then Danny, the youngest sister, was going through the origin, right? And her line looked like this, right? It was parallel to this green one, but it went through 0, 0. So it doesn't go through that anymore. She gets a 5 feet head start. Okay, so in the situation when you see head start, that's a hint where that's going to be the starting number. Here's where we see head start in the equation because it is the starting number here. What's our B in this one and B in this one? B is 0 on both of them, right? We don't see plus 0. You don't hear that plus 0 because that doesn't change the right side at all. So when you don't see a B right there, that means the line goes through the origin, right? 0.00. Y-intercept is at 0, 0. So that's something to notice here. They don't have a head start. No head start. They started their racing, and I forget who said, was it maybe Lauren, who's just like, well, they just start the race, right? That's why we don't have that's why we started the origin. We started 0, 0. Okie dokie here. I'm just kind of looking at some random person's answers because I haven't looked at them yet. So maybe we can jump. Oh, actually, it's going to populate the graphs you put in here. So we're going to look at this one person. I don't know who Pierre-Simon Laplace is. I'll look at that one later. Remember, it's anonymized. Anonymized. So it says, who will win the race at 20 feet from the starting line? How will you know this? You can use the sketch to help you show the winner. I think Gabriella will win because her line reaches distance 20 before the others. Cool. So how do you know that? How can you justify that? I don't know. Right? It does. I would maybe put a little bit more evidence in there, right? So perhaps on this one, I would say reaches distance 20 before the others. She finishes the race in how long, right? Like why do we know it's faster than the other? She gets the other. Well, here's our time right here. And the purple line, I agree, does get to 21st. So here's the thing that I didn't see anybody do. I guess you can't really sketch on this one right now. If we had a line at, well, it says you can use a sketch to help you show the winner. Oh, okay. So this isn't a sketch. So we messed up here. This isn't actually a sketch here. So anyways, this isn't a sketch. But the idea is here, if you had a line at y equals 20, that's distance equals 20, boom, it's going to hit this one first. Okay. So at about 3, or not 3, this isn't 3, this is 10 right here. So that means we're scaling by 2. 2, 4, 6, 8, 10. So this is about, we get to 20, about 2, 4, 6, maybe like a little over 6.5 seconds. She finishes the race in a little over 6.5 seconds, right? Because, oh, wait, no, a little over 7 seconds, actually. Oh, what happens if I click on this? It shows me the coordinate. Nope, it doesn't. So anyways, right, this is 6, that's 8. And then here, when we get to 20, this is a little bit closer to 8 on their x-axis here. So we can read this. This point's probably around like 7.5 or so. But I'll just say a little over 7. Oops, not y, a little over 7 seconds, okay? Why does it keep saying y? I'm going to do 7. There we go. 7 is near y on the keypad, okay? Compared to, what do the other ones finish? About 12, 14, about 12, about a little over 13 seconds to a little over 13 seconds and a little over 20, exactly 20 seconds and 20 seconds. It took her other sisters. Okay, so you can't really show it on the graph, which is kind of unfortunate. But yeah, I think a lot of people are saying something about steepness, right? Her steepness caused her to go faster. We had a 20 in only a few seconds, right? We see it. We use the coordinates to justify when x equals 20, what are their y's equal? Sorry, not when x equals 20. When y equals 20, what are their x's equal? Okay, how many seconds will it take the winner to reach the end of the 20-foot race? Cool, I just got that one there. The winner will reach the end of the race in 7.5 seconds. Gabby, I don't think it's exactly 7.5 because her slope is 8 over 3. So it's not quite that, but it's around 7.5 seconds. That's probably how I'd put it there. I know this travels 8 feet every 3 seconds, and she travels 20 feet. So it's a little bit hard to figure out. Getting to 20 feet, 8 feet every 3 seconds. So that means like 8 feet every 3 seconds. That means 3 seconds she's 8 feet, 6 seconds she's 16 feet, and then we went half that. So yeah, it is like 7.5. So she's 16 feet after 6 seconds, right? Because 8 over 3, you double that, you get 16 over 6. So 16 feet after 6 seconds. And then we just needed to go one more half up there. We need to go 4 more. And that would be in a second and a half, right? So that's actually very clever. This person's really solid there. Got 7.5. That's the distance. So a little over 7 seconds is what our graph looked like, but you could reason through it and actually prove that it's 7.5. So maybe think about that. I don't need to spend too much time on that here. Okie dokie, 129. Let's check out the next one here. You're just looking at somebody's answers here. Look at this. This is perfect. But as long as you understand this, then you're going to be set to do problems like this on your own in the future. Okay, let's describe this, what's happening throughout the race. With little Daniela having a head start, she starts in the lead. When will Gabrielle and Isabel catch up to her? What does this look like on the graph? Who reaches Daniela first? Okay, so Daniela starts first because she has the head start of 5. Who reaches her first? Okay, we got Gabriella after about 2.5. This is 2, this is 4, so it's a little bit below 4.3, so about 2.5 seconds. And we see it on the graph because their lines intersect, right? Lines interact. I like that. That's fine. That's a little bit long. Interacting. That word is intersect you're trying to think of. Intersecting lines means like two lines that cross each other. What's the point of intersection? So this is called, right here, this is called an intersection. What I'm trying to hear, when two lines cross, an intersection. So we'll talk about intersecting lines a little bit later on in this course here. And then also the other one here. So the other one, the one in red, ends about 6, and this is 8. So yeah, about 7 seconds. About 7 seconds passes the green line here. Because again, another intersection. Where's their points meet? And then beyond that, right, after 7 seconds, look, the red graph is higher than the green graph. Red graph's higher than green graph. This function is greater than this function at this point. This function is still greater than this function at that point, okay? So eventually our slope overtakes our starting number here. Who reaches Daniela second? Okay, I think they said that. Isabella, I think this is the one about 6.5 seconds. Yeah, I'd agree with that. This is 7 seconds right here, so a bit less than 7, so about 6.5 seconds. Remember, seconds is your independent variable, your x variable. And then, because the graph meets. Okay, they said after how many seconds? Up at the 10-foot line. Oh, this is a good observation. A little bit after 10 feet. That's when, right? They're where, right? A little after 10 feet into the race, that's where the little kid, right? The little kid who got the head start gets passed by her other sister. Oh, so mean. This father, this Poppy, pitting the sisters against sisters here. All right, I know there's a lot of information. You might be thinking, whoa, where is this all adding up? I just want to get you better at these problems so that, because they are in your textbook as well, so that you can kind of like think through them again. And this is a real world context, right? Lots to think of here, and rate of change and starting number, how they affect here. Describe the race from the beginning to the end as if your game announcer. What can you use in your description to tell who is ahead in each moment? The order of the girls, when one starts to catch another, when they are side by side, anything else you want to describe the race. Okay, 3, 2, 1, go. Nice, I like this. This is awesome. I really have no idea who wrote this. I have some guesses, but anyways, here. There you go, Danielle in the lead. I agree. So we're 3, 2, 1, go. They're in the lead. And then what happens? And then Gabriella shoots off real fast, okay? She's in the lead. She shoots off real fast. I like that. Not yet halfway to the race, okay? Through the race, and Gabriella rockets to the lead. I like this. Close behind her. Exactly at halfway. Ooh, exactly at halfway. What does that mean? Exactly at halfway. It's the 10, I guess, to the 10 when she's 10 feet into it out of 20. Yeah, pretty much halfway. Maybe a little bit more than halfway. Isabella, oh, wait, about 10 feet? Yeah. Okay, so a little bit halfway. Close behind her at exactly halfway. Isabella passes Daniela to get into second place here. So she's in the second place at the 10-foot mark here, which again was about 7.5 seconds. No, but at that time when she passes, it's very close to when Isabella wins the race, because Isabella passes this line at y equals 20. This will be the finish line right here. So she's already done with it when, or just about done with it, it looks like, when the Isabella passes Daniela. So this is really, what a race. Oh, what a race, so good. Who reaches Daniela second after how many seconds? Oh, we already talked about that in the last slide. Didn't that already come up? Daniela got there second. And that was the one in red here. So first, Gabby passed Daniela at about 2.5 seconds. And then here, second one, this red one here is going to pass. Remember, Daniela is in the lead right here because it's above, right? We can see whoever's above is further along, right? Whoever is above here. Remember, up, down is our dependent variable. So that's feet. So this is further along in the race. This is behind. And then, boom, we've passed here. Now this is further along. This is behind. This is further along. This is behind. For this given input, which input is time, the independent variable. So after about 6.5 seconds, right here, boom, Isabella catches Daniela and continues on upward here, okay? Eventually, we're going to learn how to solve for that algebraically, something called solving a system of equations here. All right, anyways, hope you're updating your notes. You're just trying to follow along here. Again, I wish you could have done this with your groups here. Their Poppy loves them so much that he wants them all to have fun, so he finds ways to mix up the game. Today, he is telling them that at the end of the race, he will choose which place will be the winner. Oh, nice. For this rate, he decides the person coming in second place will be the winner because faster isn't always better. That's true, right? We're all a family here. So he wants second place to be the winner. He's also deciding to make the race shorter at only 10 feet away. Oh, interesting. Their speeds or rates are the same. There we go. Use your seconds. So use your graph to help us who will reach their Poppy second. Oh, interesting that they word this. Math just words it up. Math is reasoning, reading, and reasoning. So if you're reading this clearly here. Use the sketch feature to show your ideas. Perfect. Oh, I like this here. They put in this, and I'll add to this here in black. So I'll do that here. They put in a line at y equals 10. This is a line at y equals 10. That would be a horizontal line where the y values of this entire line is 10. Remember, y is 10 feet. Okay, 10 feet, because that's our dependent variable, is feet. So here, right, this line has no slope, right? The time changes forever, and then the distance, delta y, doesn't change at all, so the slope would be 0. So anyways, this is showing when they get to 10 feet. So first, she gets there first, but the idea is whoever's the winner, who gets to me second, is the winner, right? Your poppy ever say that? And it looks like at 10 feet in, both the other girls get to their poppy, so they are the winners here. So there we go. I think Isabella and Gabriella will win by being in second place because their lines will intersect exactly at 10 feet. Look at that. Can you be in 2 places at the same time? Well, no. If you're one person, you can't be in 2 places at the same time. This doesn't make any sense at all. What are they meant to say? Can you have 2 people in the same place at the same time? Sure. Right? This is 2 people in the same place at the same time. They're both 10 feet away from the starting line at about 6.5 seconds, about 6.5 seconds. So I agree with their answer there. Hopefully you see that too. All right, Reg is starting up in 4 minutes. I think I can wrap this up pretty quickly. Race number 3. Let's get it. Let's do this here. Race number 3. How could Poppy change the game so Isabella wins? All right, Isabella is the one in red. Well, yeah, what can he say? How can he say Isabella wins? Well, I'm kind of thinking of one here. I said, okay, whoever's in last place, who's ever in third place, who's furthest behind after 4 seconds, right? That's how I could say Isabella would be the winner, right? She's furthest behind at 4 seconds, right? That's my answer right there. Let's see what this person said. If the race is 30 feet long and the prize goes to second place, Isabella would win because her line is second after 30 feet. I love it. Let's take a look at the line y equals 30. I'll go ahead and add that up here, right? Gold medal, right? So I'll go with the color gold. This is y equals 30. And boom, we get an intersection here. So it looks like a little after 10 seconds, that's when Gabby would be there. But the prize is whoever's in second place, who gets there second. And yeah, this is the one in red. This is Gabby's line right here. Yeah, no, Gabby's the one in purple. Isabella is the one in red here. So she'd be at 20 seconds, okay? At about 20 seconds here, this point here is at 20, that's a mess there. I meant to write 20 comma 30, right? For 20 seconds, she's 30 feet away, and that's going to be the second person arriving, and then her slow younger sister, Ella. Oh, poor Ella, getting there last. Okay, so I love that. Well put there. I can change the race to make sure Isabella's the winner. And what a nice poppy. And let's make sure everybody's the winner there. All right, pause for discussion. I'm sorry we couldn't really do this in class. We have other kind of racing problems. Perhaps we'll do some of those on Wednesday just to get more rate of change practice. I'm getting used to just talking about situations because these ones come up SATs and, kind of like, oh, this is what's going on here. How do we describe the rate of change? How does the starting number affect things, right? And you just got to talk about them and have a discussion on them and get good to go. All right, we won't read this person's reflection. That's the last slide because I think that's a little bit too personal. So the last thing you need to know, students is what I want to go to. There we go. Reflect on today. So that's just it here. How was class today? What did you learn? What questions do you have? Anything else you want to tell me? I know we didn't really have too much time. It took me about 13 minutes to launch things, and then you worked with your groups about 10 minutes. So not enough time to finish. I see some people are finishing right now, which is nice. So feel free to leave anything you else want here. And yeah, we're doing in pretty good shape. Linear functions chapter, rate of change. What is it? Be prepared with an answer. Be prepared to justify that at some point in time. And then what does a head start mean in this context? So you always want to find your slope and y-intercept from these linear situations, and hopefully you got practice on that here. Email me if you have any questions. Thanks for watching, guys. Bye. Time for Reg. Go to Reg. It's 1:39.